Determine the left-sided limit and the right-sided limit and the two-sided limit as x goes to -2 of the absolute value of x squared plus 3x plus 2 over 2 plus x. Each of these limits involves x going to -2 of the absolute value of x squared plus 3x plus 2 all over 2 plus x. The first thing to do is try plugging a -2 in for each of the x's. That'll give us the absolute value of -2 squared plus 3 times -2 plus 2 all over 2 plus a -2. So we have the absolute value of -2 squared, which is a 4, plus 3 times a -2, which is a -6, and then plus 2 all over 2 plus a -2, which is the same thing as 2 minus 2. So we have the absolute value of 4 minus 6 is a -2, plus 2 is a 0, over a 2 minus 2, which is a 0. Since the limit resulted in a 0 within the absolute value symbols, it is required to work out each side of the limit separately. So we will have the left side limit of -2 indicated by a negative superscript on the -2, and the right side limit of -2 indicated by the positive superscript on the -2 of that same expression of absolute value of x squared plus 3x plus 2 all over 2 plus x. Let's start with the left side limit first. First thing to do here is factor the trinomial quadratic within the absolute value symbols. It will factor into an x. In x, we need two numbers that multiply to a +2 and add to a +3. +2 and +1 will take care of that. All over the 2 plus x. And now we can separate the absolute value of that product into the product of absolute values. Meaning we can write it as absolute value of x plus 2 times the absolute value of x plus 1. Now we can analyze the absolute value that is making a 0, and that is the x plus 2. As x goes to -2, the x plus 2 will be a 0. So we're going to focus on that absolute value and look at the side of the -2 we're coming from. So we're, in this case, approaching -2 from the left side. The left side on the number line means more negative than -2, like -2.01. If we take a number that is more negative than -2 and put it into this absolute value here, like -2.01, and add 2 to it, we will have a negative number. The absolute value ensures that you will have a positive number once it comes out of the absolute value. So if what goes in is a negative number, the absolute value will take the negative of it to return it to a positive. So we can remove the absolute value symbols around the x plus 2 and put a negative in front of it with parentheses. The x plus 1, on the other hand, is not making a 0 in the absolute value, and therefore those absolute value symbols will stay. And that's over the denominator of 2 plus x. At this point, we have the 0 over 0 indeterminate form, and it will continue to be that until we can cancel the factors that are making 0 over 0. Well, x plus 2 and 2 plus x are the same thing, so we can cancel those factors out, leaving a 1 in the denominator. And so we're left with limit as x approaches -2 from the left side of the negative absolute value of x plus 1 over 1. Since we have removed the 0 over 0 indeterminate form, we can now try plugging a -2 in for each of the remaining x's. That will give us negative absolute value of -2 plus 1 all over 1. And we'll have the negative of the absolute value of -1 over a 1. The absolute value of negative 1 is a 1, and then there's a negative in front of that, over 1, and anything over 1 is itself, and so we will have negative 1 for that limit. Now we can work out the right-sided limit at negative 2. The same thing here, we will want to factor the trinomial quadratic in the numerator, and it will once again factor into x plus 2 and x plus 1 over the denominator. And we can separate the absolute value of the product into the product of the absolute values. And now we can analyze the right-sided limit of negative 2 in this absolute value here. The right side of negative 2 on the number line means less negative than negative 2, like negative 1.99. If we take a number less negative than negative 2 and add 2 to it in the absolute value, like negative 1.99 plus 2, we end up with a positive number inside the absolute value. The absolute value ensures it stays positive by not changing it. And therefore, the absolute value symbols can be removed by putting a plus outside of it because it was already positive and we don't want to change it. The absolute value of x plus 1 we are going to leave alone because that is not making a 0 as x goes to negative 2. We have the 0 over 0 indeterminate form here, but the x plus 2 and the 2 plus x can cancel each other, removing the 0 over 0 indeterminate form. We have a 1 left in the denominator. So we now have the limit as x goes to negative 2 from the right side of the positive absolute value of x plus 1 over a 1. Since we no longer have the 0 over 0 indeterminate form, we can plug the negative 2 into the remaining x's. That'll give us a positive absolute value of negative 2 plus 1 all over a 1. Positive absolute value of negative 2 plus 1 is negative 1 all over 1. The absolute value of negative 1 is 1 with that positive, so we have positive 1 over 1, which comes out to 1. For the two-sided limit, we can compare the results of the one-sided limits. Here they are. Since they do not match each other, the two-sided limit up here will be does not exist. And there's the results of the three different limits.